Welcome to San Diego Fire Rescue Department's first electric fire engine, Engine 52. This is the Volterra powertrain orientation. Upon the completion of the Volterra powertrain orientation program, the operators will understand the principles, components, operation, and base maintenance of the high-voltage components associated with the Volterra platform. This PowerPoint will include the following: an overview of the Pierce Volterra, technology, 3 different drive modes, charging system, safety items, and daily checks. The Pierce Volterra is a dual energy source pumper, meaning it has a separate battery energy system and a diesel engine. It will drive and pump in either energy mode and will automatically function like any frontline unit. The Pierce Volterra operates as a dual-source powertrain. The diesel engine and batteries are separate from each other. An important thing to note is that the state of charge for the battery system will not change with the diesel engine operation. The state of charge will change while driving through regenerative braking. Let's go over some common terminology associated with the Pierce Volterra. EMIVT is electromechanical infinitely variable transmission. TAD is transmission accessory drive. BEV is battery electric vehicle. ICE is internal combustion engine. HV is high voltage. BTMS is battery thermal management system. And SOC is referring to the battery state of charge. The Cummins diesel engine is located under the cab like a conventional fire engine. The transmission accessory drive, or TAD, is located between the engine and the electromechanical infinitely variable transmission, or EMI-VT. A clutch allows the TAD to turn with either electric power or diesel power. The EMI-VT has 2 electric motors and 2 output shafts. One output shaft is connected to the drive axle, and the other output shaft is connected to the water pump. Electric power is supplied from the high-voltage batteries located in the tower directly behind the cab. The high-voltage power distribution unit distributes power to the high-voltage components, like the inverter, which controls the EMI-VT motors. In engine mode, the engine's output shaft is coupled to the EMI-VT to turn either the drive axle output shaft or the water pump output shaft. Warnings and cautions regarding the high-voltage battery rack. The high-voltage batteries cannot be jump-started either with another vehicle or a battery charger. Personal injury, death, or damage to the vehicle could result. Also, leaving the high-voltage batteries totally discharged for an extended period of time may damage the batteries. The high-voltage battery rack consists of 2 batteries, which are 700 volts DC, made with a ballistic-grade aluminum enclosure. All high-voltage components are placed in the centralized cabinet, less than 10 feet of high-voltage wiring from the battery to distribution. Batteries are only to be accessed by specially trained mechanics with the appropriate PPE. The high-voltage batteries have a 12 to 15-year lifespan, which is designed to be for the life of the apparatus. A 30-amp shoreline is required. If the batteries are too low and plugged into less than 30 amps, the breaker will trip. The low-voltage batteries can be charged by the high-voltage batteries. The shoreline is a redundant backup. EMI-VT, aka the electromechanical infinitely variable transmission, is the heart of the vehicle and powers the accessory drive. The unique design accepts electrical or mechanical power input and operates in dual modes. Full electric mode, or full internal combustion engine operation, also known as ICE mode. The high-voltage battery is not required for ICE operation. When driving uphill, it may be necessary to use the transmission selector, down arrow, to downshift to a low gearing ratio. The range of operation in BEV mode. On a full charge, you will be able to drive about 50 miles on the highway. And driving in the city, you will get approximately a 70-mile range. On a full state of charge and pumping 1,500 GPM at 150 PSI from draft, you will get approximately 50 to 60 minutes of operation. Just to review, the Volterra operates in electric mode, also known as BEV mode or ICE mode. It can transition from these 2 modes either automatically or manually. The Volterra also has idle reduction technology, which minimizes or eliminates unnecessary engine idling. Let's review the starting process operation. Turn the battery switch on and wait for the LED Keep Alive light to turn on. Place the ignition switch to the on position and wait for the gauges to sweep completely. This is called the prove-out process and is a very important step for all of our apparatus, but especially for the Volterra. Then start the apparatus by momentarily pressing the start switch. You are not required to hold it down for it to start. The apparatus will always start in BEV mode unless the state of charge is less than 15%. If you want to start the apparatus in ICE mode, press the EV button before pressing the start switch. The green check engine light will display on the command zone screen. Then press the start switch. Here are a couple of different starting scenarios that may cause an issue. The apparatus will not start if the high voltage charge cord is connected to the apparatus, and if the start process is stopped with the ignition on and the high voltage charger is still connected. The charger needs to be removed and the ignition turned off to begin the starting sequence again. When in battery electric vehicle operations, the vehicle uses energy from the high voltage batteries, which drive the EMI-VT machines 1 and 2. There will be no tailpipe emissions created. It has the capability to drive and/or pump, and the length of operation in BEV mode will be determined by the battery state of charge. Apparatus operation will automatically start in BEV mode. Automatic transitions from ICE and BEV modes will occur when, in pump mode, when the batteries reach 12 to 15% state of charge. In drive mode, when the batteries reach 0% if the ambient temperature is warm. In drive mode, when the batteries reach 2% if the ambient temperature is cold. Even if you are at 0% battery state of charge, you can switch to EV mode when pulling into the station to keep emissions out of the station. If in ICE mode, it will run until the engine temp gets above 85 degrees. Once it is above 85 degrees, the transition from BEV to ICE mode will happen. If the temperature is above 85 degrees, the engine will run for 20 seconds before transitioning. And if started in ICE mode, it will engage the EMI-VT upon startup with no warm-up period needed. The transition of power from the high-voltage batteries to the diesel engine is automatic and largely transparent to the driver. This transition can safely happen while stationary or while driving at any speed. The driver will know the vehicle has transitioned from electric mode to engine mode because an alarm will chime from the gauge assembly and the icon on the command zone display will change from the battery to the engine. The driver will also know that the diesel engine has started when the tachometer and oil pressure gauges in the gauge assembly begin registering a position. The command zone transit screen will display the high voltage battery state of charge in the upper left corner. The mode indication of a battery icon for electric mode or an engine icon for engine mode will be displayed on the left side of the screen. The mode switch from BEV to ICE modes will occur unless you choose otherwise. The state of charge will be the automatic indicator. If transitioning to ICE from BEV mode, there will be no automatic transition back to BEV mode until the following start cycle. Regenerative or regen braking is available on the Volterra. This allows the electric motor to recapture energy during apparatus braking and store it back in the batteries. If pumping on scene in ICE mode, don't shut down if your engine is hot. Allow the engine to cool while driving or at idle, approximately 5 minutes, before shutting the engine off. Remain in ICE mode until the engine has cooled to normal operating temperatures. Through testing, Pierce pumped the engine hard and then switched to EV engine mode, shutting off the ICE engine, and then monitored the following observations. Coolant temp climbs. Hot cylinder head. No coolant flow. All of these are not good for the ICE engine. When the driver lets off the accelerator foot pedal while moving in electric mode, the vehicle is designed to provide regenerative braking to simulate normal engine drag braking on a conventional vehicle. The operator can increase the deceleration provided by regenerative braking using the Telma switch in the cab to either low or high settings. You can also turn off the Telma using the on-off auxiliary brake switch. The EMI-VT is an infinitely variable transmission with two primary ranges, medium and high. When starting, the EMI-VT is in medium range. The driver can expect to only feel one shift event as the transmission transitions from medium to high range around 20 miles per hour. The ICE engine layout is configured as a backup internal combustion engine. It is a smaller engine than the current Type 1 apparatus. The diesel engine is sized to run the pump. It is a Cummins B-Series engine that has 360 horsepower at 2,600 RPM. While operating in ICE mode, diesel fuel is required to power the ICE engine. It does create tailpipe emissions. It has the capability to drive and/or pump, and there is no effect on the high-voltage battery state of charge. When performing pumping operations, you can pump in either ICE or BEV modes. To engage, you must set the parking brake, place the transmission in neutral, and then utilize the road-to-pump switch. The Volterra has a pressure governor at the engineer's panel to control pump output, rather than the traditional engine throttle and pressure relief valve located on all of our other pumping vehicles. While pumping, there is less than 3 psi difference when switching between BEV and ICE modes. It still has RPM limit protection because the pressure governor does not know its source of either BEV or ICE. Let's discuss the typical operation of the Volterra. When you're leaving this fire station with a battery state of charge greater than 15%, the vehicle leaves in electric, BEV, mode. When you're leaving the fire station with a battery state of charge of less than 15%, the vehicle leaves in ICE mode. It will remain in this mode for the remainder of the trip. When in electric mode, either driving or in neutral, and your battery state of charge drops to 2%, an automatic transition to ICE mode occurs and will continue to remain in ICE mode for the remainder of the trip. Let's discuss the typical operation when arriving on a fire scene while in electric mode and engaging the water pump. The water pump will engage with the currently selected energy source. When disengaging the water pump and leaving the fire scene, if your state of charge is greater than 15%, the vehicle will remain in the selected mode. When you disengage the water pump and leave the fire scene, if your state of charge is less than 15%, the vehicle remains in engine mode for the remainder of the trip. Now let's look at a driver-initiated transition from electric mode to engine mode. The vehicle starts in electric mode, and the driver presses the mode switch on the shift selector and transitions to engine mode. The vehicle is now in engine mode. Here's an example of a driver-initiated transition from engine mode back to electric mode, assuming the vehicle was started in electric mode. The vehicle was manually placed in engine mode, then the driver presses the mode switch on the shift selector. If the state of charge is greater than 15%, the vehicle transitions to BEV mode. Or, if the battery state of charge is less than 15%, the vehicle will remain in engine mode. The engine clutch allows power to the transmission accessory drive, or TAD, and the TAD runs the 24-volt alternator, yellow wires, the brake system air compressor, and the air conditioner compressor. Note, the power steering pump is coupled directly to the EMIVT. This allows accessories to always be driven, whether it is powered by EMIVT in BEV mode or powered by the ICE in engine mode. In this next section, we will review charging basics, charging ports, AC charging, and DC charging. Here are some of the important features of the 12-24-volt battery system. The 12-24 Keep Alive light needs to be on in order for the charge process to begin. If the 12-24-volt batteries are low, charging contactors may not close. The 30-amp shoreline will keep the low-voltage batteries charged, and the apparatus will not start if the high-voltage charger is still connected to the apparatus. Standard high-voltage charging port contains an electric motor to lock the plug in place during charging. There is no auto-eject feature for the high-voltage cord. You must remove it by hand. The plug will not release until the green charging light is off. You must depress the stop charging button next to the charging cord. Pressure on the locking pin will remain until the light is out. There is also an internal conductor temperature sensor that monitors the charge controller. It is not necessary to discharge the batteries on a PM interval. There are no issues with topping off the batteries. There are some very important safety items to review for the Volterra. Some of these are the high-voltage interlock loop and the high-voltage component positioning. Be aware of safety tags and labels on the Volterra, of danger, warning, or caution. The electric drivetrain in this vehicle uses high voltage, up to a maximum of 750 volts direct current. Never disassemble, remove, or replace high voltage parts or cables, as well as their connectors, because they can cause severe burns or electrical shock that may result in serious injury or death. High voltage cables and wires are orange. Orange cables connect the high voltage system components and can carry voltages as high as 800 volts. Never disconnect, touch, manipulate, step on, or attempt any repair on any orange, yellow, or other cables on the Volterra. Only specially trained mechanics with the appropriate PPE can work on this apparatus. Always contact San Diego Fire Department Fleet Operations and be guided by their direction. There are 3 high-voltage disable cut loop locations on the vehicle. They are located on the lower right side of the battery tower, on top of the battery tower, and on the lower left side of the battery tower. Each cut loop location is clearly labeled with a first responder graphic. Cutting any of the 3 loops will open the high-voltage contactors and disconnect the high-voltage batteries from the chassis. The cut loop circuit is a low-voltage signal wire. Cutting the wire does not present a risk of electrical shock. EMIVT fluid check must be done when it is not running and the pump is not engaged. Fluid reservoirs are located on top of the battery bay and on the captain's side battery cabinet. Contact fleet if any fluid is needed for this apparatus. On the internal combustion engine, or ICE, you will need to check the coolant level, located on the radiator, and oil level daily. Every Tuesday, you will need to start up and run the apparatus in ICE mode and drive it at freeway speeds for a minimum of 30 minutes. You must allow the engine to go through a full and complete warm-up cycle before shutting down. You will need to lubricate all moving parts that have Zerk fittings, as this apparatus does not have a Vogel automatic lubrication system like our other apparatus. The Pierce Volterra electric fire truck is equipped with a sophisticated thermal management system to counteract the adverse effects of low temperatures on the battery. The system includes a coolant loop which circulates around the battery area and a small electric heater. During cold weather months, the coolant is heated to prevent the battery from falling below a certain temperature threshold to ensure optimal performance functionality. In the summer, the system operates inversely. The coolant is run through a radiator, similar to a conventional car, to prevent the battery from overheating. If temperatures rise excessively, the cooling system is employed to cool the batteries to maintain a consistent battery temperature. The thermal management loops include the following: the Battery Thermal Management System, or BTMS, the Power Electronics Management System, or PTMS, and the Cab Heat Thermal Management System. There is a cabin heat overflow bottle located on top of the battery. The fluid level is visible through the cut loop panel. The Battery Thermal Management System, or BTMS, is located on the captain's side of the lower battery rack. You can check the level using the Command Zone screen, BTMS coolant level. Have fleet mechanics refill the coolant if levels fall below 90% on the Command Zone, or if you notice a drop of 10% or more. The Battery Thermal Management System, or BTMS, contains both batteries, has one pump with distribution manifolds, a chiller, and a heater. The reservoir is located on the captain's side, lower battery cabinet. The Power Electronics Thermal Management System, or PTMS, fluid overflow reservoir, is located in the upper battery rack section. The level can be seen on the Command Zone screen live data under PTMS coolant level. The Cab Heat Thermal Management System fluid reservoir is located on top of the battery rack. The fluid level cannot be seen on the Command Zone screen. Here's a diagram of the Battery Thermal Management System for reference. Here's a diagram of the cabin thermal management system. The cabin heaters are located under seats. The heat exchanger uses the ICE engine, heat, or the high voltage heater to support the cabin heat. During ICE operation, the flow to the heat exchanger, or HEX, is controlled through the opening and closing of valves. During BEV mode, the valves are held open and control is done through the CAN control of the high voltage heater. Additional videos are available at sandiego.gov/fire/training. One video reviews the charging process for the Volterra at Station 52, and another reviews the use of the Pump Boss pressure governor pumping system. Forward any questions to the driver training officer or contact fleet operations.